Now in this video we are going to focus specifically on the compound interest formula that we just learned about. And so to recap that, the amount A after t years due to a principal P invested or borrowed at an annual interest rate R compounded n times per year is, and so I'm going to read the formula, A equals P times, and then in parentheses 1 plus R divided by n to the power of n times t. So basically we divide the rate that we have. So in our example we focus on the same example again that we had in the previous video, and that is we're gonna borrow $2,000 at 5% interest for 4 years, and we're gonna compound it differently. And so our 5%, our rate, so 0.05, is going to be divided by however often we calculate our interest, and then we take it to the power of not just the years but also times the number of times we actually calculating the interest per year. Let's see how this works in action. We had it for annually, so that we did in the previous video, and so in this video we are going to compound it quarterly, monthly, and daily, and then we're gonna look at what happens to our values. So for the first one, it is A equals 2000 times 1 plus our rate is always the same, and in this case, so quarterly, that means 4 times a year we are going to calculate our interest, and then therefore to the power of 4 times 4, and then when we put that in our calculators we will find that that is $2,438.78. So after 4 years you will owe $2,438.78. Let's see what changes when we compound monthly. So we have A equals 2000 times 1 plus 0.05. Until now our formula is the same. However, now monthly means that our n equals 12. Maybe it would have been helpful to write here also n equals 4 when we calculate quarterly, and we divide therefore by 12 by our n, and then to the power of 12 times 4, and again we plug this into our calculator and get $2,441.79. So after 4 years you will owe $2,441.79. Now if you look back at our previous answer, you will notice that there's a slight increase by about $3, and if you remember the number before that, for annually it was $2,431, so that was $7 increase to quarterly. And now even though we compound monthly, that means quite a bit more time, 12 times, so instead of just 4 times, really we're only getting $3 out of that more, right? So that means you can start thinking about, is it worth your effort, or is it worth the effort of the bank to always calculate that and so many times? But just for the sake of practicing, let's take the compounded daily and see what the change is then. And so here we are just going by that the regular year, so the fiscal year is always considered to be 365 days, even if it's a year that has 1 day more. That's just, it's a standard for all our formulas. We just go by that, that's the number of days. And so our formula then becomes A equals 2000 again times 1 plus 0.05, but now we divide by 365, and then we take that to the exponent. Again, here goes our number of compounding, so 365 times 4 years, and our answer in this case will be $2,442.77. And so that's a stunning, not even quite $1 more. So after 4 years you will owe $2,442.77. So if the bank continues every day to compound your interest, they will get for all their effort 98 cents more from that. So you start seeing a little bit why banks actually compound mostly quarterly. That is definitely some significant amount to just doing it yearly. But after that, it becomes not quite worth the effort after that. And that was kind of the purpose, also a little bit of showing that, but also to practice how to use this formula to then, when we have all the numbers, to find what amount we would either gain or, in this case, owe at the end. And then we will, in the next video, look at a little bit more of this and then see kind of how the limit comes up, how we can, even we go by the minute and by the second, it doesn't go past a certain number, which we will call E. And so we will do that next, and then after that we will actually practice our newly found logarithm skills in actually then trying to find out, well, how long, for instance, we will have to put money aside to reach a certain amount when we want to save, or how long we will have to pay something off if we pay a certain amount off every month.